Welcome to the lecture on Tundish metallurgy. So, we have already discussed about the role of Tundish in continuous casting, and we know that the Tundish is acting as a metallurgical reactor, and because the steel is coming from the ladle and then going from the Tundish to the mold. So, some of the treatments are even done before the metal enters into the Tundish, and of them includes like there may be treatments to the melt, so that certain kind of inclusions are or inclusions are basically filtered out, or for controlling the composition of the steel also. However, we must know that what are those aspects also which needs to be studied regarding the treatment which is done in the Tundish also, which has basically the bearing on the metallurgical behavior of the product, and what are those capabilities which affect that way. So, that basically will be covered under the aspect of this topic, that is Tundish metallurgy, and especially we will talk about those phenomena which take place inside, like we can have certain treatments related to the modification or treatment, so that the inclusion removal is more, or other aspects like the vortex formation or so. So, we will have the light on these aspects. So, what we see that normally as a metallurgical reactor, we feel that in the Tundish there should be the Tundish should be working in such a manner that there should be even heat throughout the domain in the Tundish. Then there should be proper flow configuration inside the Tundish, so that there is proper use of the space which is there, or proper use of the volume of the Tundish. Then you have to do something also, your flow control has to be such that there has to be minimum of the inclusions which should further go down the Tundish from the Tundish outlet towards the mold. And also we need to see that how you have to see that there is no vortex formation. When there is a decrease in the level of the Tundish, then there should not be vortexing phenomena and all that. So, one of that process is that you may have certain additions like inclusion modifiers like calcium or calcium silicon at the very last minute in the Tundish itself. So, what happens that although we do certain treatment, so that inclusions are we try to trap them, we try to see that minimum of the inclusions come into the Tundish, but still if the inclusions are coming inside the Tundish, then we need to have certain treatment, and maybe sometimes we add like inclusion modifiers like calcium or calcium silicon at the very last minute in the Tundish. So, so that basically will help in the control of the inclusions, or it will help in the treatment of the inclusions, so that inclusions either float or inclusions are modified. There are modifications to those shape and size of those inclusions or their properties, so that ultimate aim is that these inclusions should be minimum in the melt. Other aspect is also about the temperature adjustment in the Tundish. Because from the Tundish it is directly going to the mold, and if the temperature becomes very less, so in those cases that may affect the quality of the cast, because it has to go into the mold, and then further it has to be it has to get solidified. So, many a times what we do is we do the heating, we have the heating arrangement also in the Tundish, so that you see that the proper temperature is maintained throughout the Tundish volume. We have already talked that there may be change in the flow pattern because of these temperature differences. There may be formation of the convection loops, there may be thermal current which may be there inside that Tundish. So, that may alter the flow configuration inside the Tundish. And many a times if the temperature is becoming very small in certain areas, which is most likely a dead region inside the Tundish, in those cases you need to have the temperature adjustment mechanism. You need to heat the Tundish also in those the liquid in the Tundish in those areas, so that the temperature is well above its melting point, so that there is no undesirable thing happen like solidification inside the Tundish itself. So, we do the plasma or induction heating especially when we wish to cast with very low superheat. So, especially when we are trying to cast with very low superheat, and if there is a temperature drop, undesirable temperature drop in certain region, then that may be producing some undesirable outcomes. So, in those cases we have to go for certain kind of heating mechanism like plasma or induction heating. So, that is also done. So, ultimate aim, our ultimate aim in the Tundish will be to have the clean steel, and that is because the requirement for the steel has been increasing over the years. So, it is because that they are used for critical applications, and the presence of these inclusions make the properties of the steel inferior. So, what has been the practice that we try to improvise those technologies. We are working on the better technologies, so that we can get rid of the inclusions. And in fact, our effort is to go for the inclusions, because there are mechanisms to filter out the larger size inclusions, but then we have to see that these sized inclusions, critical size inclusion sizes become less and less, which must be removed. So, it is because all these properties like strength, ductility, durability, corrosion resistance, so we are working on it to have its improved properties over the years, and also that is possible normally if you are making the steel cleaner of the non-metallic inclusions, which are most likely deteriorating these properties, for which we normally use steel. Like if the inclusions are there, the strength may go down, ductility may go down, and durability as well as corrosion resistance, all these things are impaired, all these properties are impaired if you have the presence of these non-metallic inclusions. If you talk about the non-metallic inclusions in the steel, normally they are of two type. One is the indigenous oxide inclusions. So, they normally are formed by the deoxidation of the steel melt, and then you have exogenous inclusions. So, there are basically these are the two types of these inclusions. So, if you talk about these indigenous oxide inclusions, so they are basically removed during the refining and degassing of melt in the ladle itself, as we discussed that we do certain treatment in the ladle itself. We try to remove these indigenous oxide inclusions by during that refining as well as the degassing of the melt in the ladle. But some of these non-metallic oxide inclusions of a small size still remain suspended in the melt. So, they will be coming to the Tundish. And then if you have the second variety of inclusions, that is your exogenous inclusions. So, they are formed by the reoxidation of deoxidized steel melt by air or by the entrained slag into the melt during the melt transfer from the ladle to the mold. So, that basically is because of the reoxidation of these deoxidized steel melt which we have done. So, that there is further chances of reoxidation, and also because of these slag which is these that slag into the melt which may pass down. So, what happens that these inclusions which are of the exogenous origin, so which is formed because of the reoxidation, so they are normally much larger than the indigenous ones, and they are very harmful. So, larger inclusions will be harmful than the smaller ones. So, how they are harmful, because these inclusions what they do is they will be causing the problems during the casting, rolling and heat treating processes. So, as you know that if there are inclusions, they will be as the defect in the cast product. If they are in the rolling, so rolling also they make difficult, and also during the heat treatment process. So, in all these processes, because when there are inclusions, their property is not as same as that of the parent metal, it has not the ductility same, normally they are brittle. So, what happens that they result in the failure of the steel during its application. So, that is why these inclusions are said to be removed. Mostly we try to remove these inclusions as to the extent as we can. So, steels with more demanding processing and applications require inclusions which are smaller in size and number density. So, it means that if you have to have steel of better quality, so there the requirement is that the inclusion size should be smaller, and similarly the number density also should be less. Less number of inclusions should be there, as well as the smaller inclusions you try to have that. So, that is why your more demanding processing and applications are required nowadays, and critical inclusion size decreases as demands become more and more stringent. So, you say that the inclusion size should be not more than this size whenever we talk about those very demanding steels, or wherever you have to use the steel for the critical applications or so. So, the end user will specify that the critical inclusion size should be this one. It means you should not have an inclusion which is of larger size than a particular size, that is your critical size of the inclusions. So, what happens that these larger inclusions are there. So, they will be elongated in the steel matrix as thin stringers along the rolling direction. So, what happens that when you have larger inclusions and when you roll these slabs or billets or ingots itself, when you are further going for the rolling operation. So, they are likely to be elongated and they will be like thin stringers in the rolling direction. So, if you have the rolling direction like rolls are moving, so like this upper roll like this and lower roll is moving in that way. So, it will be taking the strip in forward direction, and your larger inclusions, so they will be elongated in that direction. So, they will be, if it is of this size, so they will be flattened, and it will be in that in the rolling direction they will be elongated. Now, further when the hot rolled these steels are further subjected to the cold rolling, then what happens that as the temperature comes down, so they become brittle, and then when you are doing the cold rolling, so they will be breaking into the pieces of small size, because they will be brittle at the cold rolling temperature, and that will be affecting the homogeneity of the component. They will be affecting the properties of the material, and then there may fail also at those points. So, what we do is harmful effect of these large inclusions which we get, they can be reduced by modifying the chemical composition of the inclusions to lower their melting temperature and to make the inclusions deformable during hot rolling. So, as you see that if you have the larger inclusions, so the one way is that you can use these modify the chemical composition of the inclusion so that you can lower their melting temperature, and then the inclusions can be made deformable during the hot rolling. So, one of the way you can have their effect less and less harmful will be by making these treatments. Then impurities which are dissolving in the melt and form precipitates during solidification. So, you have also impurities which may be dissolving in which would like to dissolve in the melt, and it would like to form precipitates during the solidification. So, you also need to minimize them as well. So, that also needs to be done, so that your steel becomes cleaner and cleaner. If you look at those impurities, typically you have phosphorus and sulfur. So, these elements will form phosphides or sulfides. So, these phosphides, they will be at the austenite grain boundaries, and sulfides will be in and around the austenite grains. So, normally they are making this formability of the steel, they challenge that property of the steel. So, as it is difficult to remove these impurities in the Tundish, because so they have to be this should be minimized during the hot metal treatment, the BOF process and the ladle furnace processing before bringing the melt to the continuous casting station. So, once they are coming to the Tundish, it is very difficult further to remove them, because they have to be removed through the treatment, through certain reactions, chemical reactions or so. So, your efforts should be there, so that during the hot metal treatment, like in the BOF process or in the ladle furnace processing, before you are bringing to the Tundish itself, you try to remove try to have minimum of these phosphorus and sulfur and the formation of the phosphides or sulfides at the grain boundaries. So, this needs to be ensured, so that the chances of having those compounds formed at the grain boundaries or in and around these austenitic grain boundaries is minimum. So, what we do is normally we go for the flotation of inclusions. So, one of the way is that you try to have the flow structure in the Tundish in such a way that the inclusions have the tendency to float up. So, even with the best ladle metallurgy practice, some inclusions particles will be retained in the melt. So, as we discussed that we try to do the treatment in the ladle, so that most of the inclusions we are trying to remove from there itself. But still as we had seen the some of the inclusions, they are likely to still come in the Tundish, and we have to try to remove these inclusions. So, there cannot be any such treatment as we can do earlier to the ladle or in the ladle itself. But then by altering that flow pattern, we can think of doing something so that these inclusions can be removed. And one of the way is that by managing the residence time of these particles or the flow of the melt in the Tundish. So, if the adequate residence time is being provided in the Tundish, there will be opportunity for at least the larger of these inclusion particles to float out. So, as we had talked about these role of these Tundishes in the casting. So, there also we had talked that these steels which are going steel which is coming inside the Tundish. Now, these fluid particles spend certain time inside the Tundish. So, it has some time before it comes out of the Tundish outlet. Now, this time, that is your residence time. So, if it is very small, these inclusion particles which are coming inside the Tundish, they very so it will have a smaller and smaller chances to come out of it. So, the way is that you give adequate residence time. So, you should have the flow structure in such a manner that once the liquid steel comes there. So, you should have the flow in such a manner that you have the time, sufficient time for these inclusions, especially the larger inclusions to float out, because the larger inclusions are having a smaller density as compared to the melt. So, once they are settled and they have some time, then in that time basically they will be subjected to the buoyancy forces because of the smaller density, and then slowly they will be floating up. So, that is known as the flotation of the inclusions. So, that is a natural phenomena which has to occur because of the density difference, and normally density difference will be about 0.5 to 0.6 times, or maybe can go up to 0.67 times also. So, they will have the chance to float up, but for that, as we talked, that the residence time has to be adequate, and if the residence time is less, we can do something by which the residence time can be increased in the Tundish. So, those are the means why there are many means, like you may use certain flow modifiers, or and mostly by that, or you can have a Tundish design where inlet and outlets are positioned in such a manner that your residence time becomes maximum for a particular configuration or for particular geometry of the Tundish, or with the use of flow modifiers. If the residence time is short, or the Tundish is poorly designed, so that short circuiting or bypassing occurs, the inclusions will be retained, resulting in poor quality finished product. So, what happens that if your Tundish is such that the inclusions residence time is very small, in that case the inclusion which is coming inside the Tundish, most likely they will try to go directly towards the outlet, and they will be going towards from the Tundish outlet to the mold, and once they have entered into the mold, certainly there will be more likely that these inclusions become part of your product, and then when they are coming going inside the solidified region, so they are trapped, and then that becomes a part of your product. So, they are likely to be further rejected. So, you have to see that you avoid these short circuiting or bypassing. So, and mostly it occurs because of very poor, sometimes poor design of the Tundish, or you have not used the properly these flow modifiers in the Tundish. So, all these concerns need to be addressed before and you must check that what is the average residence time, so that you can be sure that if the residence time is larger, then if there is inclusion, they are likely to be going at the top of the the Tundish surface. So, and there they will be trapped. So, that is how these inclusions are removed. Then comes another aspect which needs to be understood is in the case of Tundish is the vortexing. So, This phenomena is of concern when your vessels or containers are being emptied. So, as you know that the ladle will be bringing the liquid steel from the shop, and then they will be emptying that into the Tundish, and the Tundish will be delivering the melt to the mold. Now, one ladle when it is emptied, then another ladle comes, and if there is if you need to siphon out all the liquid metal in the Tundish, so that your next cast grade is of a very dissimilar type. In that case, you need to lower down, and then further you are pouring in the another grade of steel into the Tundish. Now, while emptying, when the level will come down to a certain height, then there may be a vortex formation at the outlet, particularly when the liquid level will fall below a critical value. So, what happens that when the liquid level will come down, so that can be understood, like you have the this is the Tundish, and if suppose you have the outlet here. Now, what happens that when this is your inlet and liquid metal will come out. Now, what happens that when we use the you may use the flame modifiers or so. Now, this is the level, and it will be coming down, and once you come to certain level down, then you may have the formation of these vortexes, and this vortex formation is nothing but because it will be happening when the level will be falling down to a certain level. So, that is critical level, and this vortexing is nothing but what it does is it will try to entrap the air, and that air bubbles will be appearing, and then that will be going inside, that may try to oxidize the steel. So, that is harmful. So, we do not want the level to go down below a certain limit, that is vortexing. So, particularly when the liquid level will be falling below the critical value, and such vortexing is basically undesirable for both ladle as well as the Tundishes. In both the cases, if the vortexing occurs, it may lead to the air as well as the slag entrapment, because at the top you have the slag layer, and if there is vortexing occurring, in that case the air or the slag may be entrapped and it may go inside, and once it goes inside, then that will be that may be likely to have there is likely to have the slag inclusions, or there may be oxidation, and there may be formation of inclusions, there may be oxidation of the melt also. So, basically you will have to see that these vortexings is avoided. So, this vortexing we can minimize through the correct Tundish design, and in particular through the appropriate placement of weirs and baffles. So, these vortexing can be minimized by if we have proper Tundish design, as well as the Tundish furniture we use, that is your weirs or the baffles or dams. So, you must have the appropriate placement of these weirs and baffles. So that basically helps in ensuring that there is no vortexing in the Tundish. So, so that is another part which has to be taken care of while we try to see that what should be those mechanism by which you can avoid these vortexing. Apart from that, we also talked about other mechanisms are there, like you have the heating mechanism, you can use the plasma torch, we do the other heating mechanisms, so that the temperature are kept homogeneous inside the Tundish, because and in many cases, as we have studied, in most of the cases it is challenging when we are using the steel of which is to be used with very low superheat. So, there are some ways by which all these plasma heating or with other mechanism you can have those you have a plasma torch. So, that is being used normally for maintaining that temperature. So, all these aspects needs to be studied, and we will be talking about them in the lectures to come. Thank you very much.